Okay, this is NC pre-calculus, and we're going to do a Ferris wheel problem. And this is a sinusoidal story problem. It means I'm going to incorporate a sine or cosine graph. What I'm going to start out by doing is going ahead and drawing a Ferris wheel. So I'll go ahead and get rid of this. And if I look at my important information, you'll see up here I have a Ferris wheel that has a diameter of 48 feet. This particular Ferris wheel makes 1.5 or 1.5 revolutions per minute. And then another piece of information is this Ferris wheel is 6 feet above the ground, which hopefully makes sense because a Ferris wheel shouldn't be sitting on the ground. So if you look at my picture over here of this Ferris wheel, okay, here's my 6 feet off the ground. And that makes sense from here to here. And if the Ferris wheel has a diameter of 48, hopefully you would notice that the radius of each would be 24, which is a total of 48. And then this also helps us because I need to know the midline here. What is my horizontal shift of this particular graph? And if it's 6 feet off the ground plus 24 feet for the radius, that means that the middle of this Ferris wheel is suspended 30 feet in the air. Okay, we're going to go ahead and make an equation here in radian mode, or a function, and we'll do it in function notation. So what is the height with respect to t? And I know it's going to have a vertical shift of 30. So at the end it's going to be plus 30. All right, so as we're going through this graph, I'm going to think about what happens to a Ferris wheel. So when you get on a Ferris wheel, okay, you're going to go ahead and get on the bottom of a Ferris wheel, and then you're going to go up to the top, and then you're going to come back down to the bottom. One full rotation, okay, or in this instance, one full period. So if I think about it, I'm going to start at the bottom. I'm going to go up. I don't know what my time intervals are yet, to the top. And then over time, I'm going to come back down. It's going to look something like this. And I'm not sure. That's not perfect yet. Okay, so that right there looks like a cosine graph. And in fact, it looks like a flipped cosine graph. So we'll go ahead, and we know it's going to be cosine. And we know it's going to have a negative here to flip it. And my amplitude of this graph is just going to be the radius. So I would put 24 right here. And this out here again is my vertical shift. Okay, so we're pretty close. I need a variable here. I'm going to use t. I could put the period here inside the parentheses or outside. Now my calculator is going to force me to put it inside because it just automatically adds this first set of parentheses here. So I'm going to put the period inside the parentheses. Shouldn't make a difference because we shouldn't have a horizontal shift on this. Now here's where the 1.5 revolutions comes in. 1.5 revolutions, okay, per 1 minute. That's 1 minute. Now the problem with this is I want my graph in seconds. So I'm going to change that to 60 seconds. Now you'll notice when I was highlighting this and I was going around this Ferris wheel here, when I want to make one full period of cosine, I go one time around, not a time and a half. Okay, that wouldn't make sense to go 1.5 times around. So I need to convert this. And I need to know, what about 1 revolution? Okay, and then how many seconds would that take? So I'll call this x seconds. So I'm going to do a proportion here. And I'll cross multiply. So cross multiply that times that equals this times this. And you get 1.5x equals 60. And now we just divide. So I'll go ahead and get my calculator out. 60 divided by 1.5 is 40. So that means this thing should make 1 revolution in 40 seconds. All right, and here's what my graph looks like. One of the parts that's difficult about a graph is it's not going to always give you the time intervals and how far you should spread it out if a graph's not provided. So I just kind of came up with these, working my way through the problem. And we're going to put some things on the graph here, and then we'll come back to the equation. So I'm going to start off with what I know. Number one, I know my center line. So I'll go ahead and plot that at 30 here. So I'll make a dashed line. This is my vertical shift at 30. And then I'm going to do my amplitude, which is 24 here. So here's my amplitude. And that means from that 30 line, I'm going to go up 24 and down 24. And you'll notice, I'll do a dashed blue line on this. It's not actually my graph, but it's going to help me make my graph. I'll go up 24 and I'll go down 24. And you'll notice I went in increments of 6 because it works out perfectly. And then last but not least, I need this thing to make 1 full rotation at every 40 seconds. So I'm going to do a dashed vertical line here at 40 seconds. And then I'll do another one since I have room here at 80 seconds. And now I'm going to graph this cosine graph. So I'll go ahead and make a dot down here. I start at the bottom at 6 feet at 0 seconds. Okay, I need to go up to the top and back down and end at the bottom here at 40 seconds. 1 full rotation. It's all about splitting in halves and quarters here. At the halfway mark, I should be at the top. At the quarter-way mark, I should be at the midline. Same thing over here, midline. And breaking up in increments of 10s worked out perfectly. I'll do it for another cycle. So at 50 seconds, I should be at the midway line. At the top at 60 seconds, midway line at 70, and at the bottom at 80. Okay, and the reason I went to 80 is because that's what it asked in the instructions here. I was just conveniently able to flip or put in 2 full cycles. Okay, now I'm going to connect this with a nice smooth curve. So up, through, over, down. Okay, there's 1 full cycle of a full rotation, 1 revolution of the Ferris wheel. Up, over, connect, and down like that. And we have 2 cycles of a flip cosine graph. Okay, the next part is I'm missing my B here, the part that affects the equation to make this specific graph, because I actually want this period to end at 40 seconds. Okay, so I'm going to do a little side math down here, and we have an equation for sine and cosine graphs for the period. It's 2 pi over b, and I want to know when is that going to equal 40 seconds. And now I'm just going to do a little algebra here to get b by itself. So I'll go ahead and multiply both sides by b. I get 2 pi equals 40 times b. And then the last step would be to divide by 40. Divide by 40. And I can simplify this. 20 over 40 would reduce to 1/20. So b is equal to pi over 20. And that will be what needs to go in my equation in order for this thing to actually finish a full cycle at 40 seconds and finish the second cycle at 80 seconds. So in this space right here, we'll go ahead and put pi over 20. Okay, the next part of this, it says use h to estimate a person's, should say, height above the ground at 13 seconds and 30 seconds. Well, I don't mind 30 seconds. I can see it right here. Okay, it's a nice clean point on my graph. At 30 seconds, I should be at, oops, let me undo that. At 30 seconds, I should be at a height here of 30 feet. Now, the problem I have is with 13. 13 is not a clean point. If I look up here, let me try that again. 13's roughly there, and when I go up, it's not a nice clean number, and I don't want to just guess. Okay, so I'm going to use my calculator at this point. And I'll go ahead and get rid of that. And I'm going to type this equation into the calculator, and then I'll use a table and I'll find exact values. So here's my equation. I'll go ahead and get my calculator up and running. One thing that's important, you'll notice I'm in radians mode because I have pi, okay, in my equation. So when I turn the calculator on, clear, go to mode, make sure radians mode is highlighted right here, which it is. I'll go ahead and type this into y equals. You notice I pre-typed mine in. And then I'm going to look at the table. So I'll go to the table, and then I'm going to scroll down, and I'll get to 13. And 13 says I'm at 40.896 roughly. And that looks about right from my prediction. When I looked up at 13 here, yeah, 40, I could see that. That's pretty close estimate. And then also I'll go down to 30 seconds, and we'll see where we're at. And at 30 seconds, it should be at a perfect point, and it is, so I know my math's correct. So there's 30 seconds. I'll go ahead and pull that off. And then here's 13 seconds. I'll go ahead and pull that off. And here's my two answers. So at 30 seconds, I should be at 30 feet. And at 13 seconds, I should be at 40 point, and they asked me to round to, they don't ask to round. What do they ask? Let's do it to the nearest tenth. So the height at 13 seconds is approximately equal to 40.9 feet. There's one answer. And the height at 30 seconds is equal to 30 feet. And there's the second answer.